Alright guys, in this video I'm just doing a little bit of practice for the infinite geometric series. So I've got my formula ready. Alright, and the first thing you want to do when you're working on these is to figure out, is it a convergent series or a divergent series? So to make that decision, remember, it's all about your common ratio. If the common ratio is less than 1, it will be convergent. And if the common ratio is greater than 1, it'll be divergent. So that's the first thing we need to check on. So when you're looking at your series over here, think about how do you get from one term to the next. So to get from 180 down to negative 60, or from negative 60 to 20, I'm going to be dividing by negative 3. Dividing by the negative is how it changes the sign back and forth. So that makes my ratio, my common ratio, negative 1/3. So if negative 1/3 is the common ratio, that's less than 1, which makes this a convergent series. So I need to keep going. That means I can find the sum of the series using the convergent series formula. So I'm finding the sum of an infinite series. Notice that the formula does not have an n value, and that's because the n value is infinite. It keeps going and going and going. And I'm just going to plug in each of my values. The first term is 180, and we found an r value of negative 1/3. Okay, just be careful of how you input that over into Desmos. You should get a final sum of 135. Okay, I'll do these odd problems with you, and you can try the even problems. All right, when you're working with an infinite geometric series, first thing is to decide what's the r value, because that's going to decide if it's a convergent or divergent series. So let's find that r value. What is happening from one to the next here? These are a little bit more difficult because they're fractions. So something that you can do is you can just take any term and divide it by the term before that, and that'll get you your r value. So if you need to do that over in Desmos, go right ahead. This might not be something that's like the simple math that we're used to doing in our head. So let's just see. 9/2. You could turn that into a decimal. That's 4.5. And 4.5 divided by 3 is 1.5. So our r value here is 1.5. And you could do that with any two terms in the sequence. If you wanted to start with 27/4 and divide that by 9/2, you'll still get 1.5. Okay, so this is really important. This r value is 1.5, which is bigger than 1. So this is a divergent series, and we are done. We cannot find the sum of a divergent series. There is no sum of a divergent series. It's not a specific number. So we're finished with this problem because of the r value, that common ratio. All right. The rest of the problems on my page are in summation notation. So I like to try to do one with you by hand, but I know that you're going to be working on these in Desmos with the sigma notation. So let me do one with you by hand. Something you may want to jot down here is your geometric sequence formula. The geometric sequence was a sub 1 times that r value to the n minus 1. And that just helps you pick out everything here. If you had to know what is the r value, sitting right here. The r value is negative 1/5, which means this is a convergent series, which means I can find the sum value. If I'm using my convergent sum formula, okay, I'm finding the infinite sum. My a1 value is here, negative 1/4, over 1 minus the r value, which is negative 1/5. It's a pretty easy formula, especially since we don't have to memorize it. Okay, be very careful when you're plugging that in. I know I keep saying that, but I don't want the plug-in to be why you may get one of these wrong. And you should get a sum of negative 0.2083 repeating. Okay, let me go with you over into Desmos and show you how to input this with the sigma notation, because I know that's probably what you're going to choose. That's much easier. I just thought, of course, they want to see it with the convergent series formula. Who wouldn't? It's awesome. All right, so functions, miscellaneous, sigma notation. This formula had a k in it, so I'm swapping that out for k, and it was from 1 to infinity. Now I'm just going to start with 100, see what happens. Okay, we'll see how that goes. So we had negative 1/4. Oops, excuse me, I thought that was a parenthesis. Negative 1/4 times, I need another parenthesis, negative 1/5. Okay, and then outside of negative 1/5 is where I'm going to need to put my exponent. And my exponent is also going to have to be put inside a set of parentheses. That way everything stays in the exponent field of Desmos. So it's not very pretty. Desmos kind of makes it look yucky. I know this isn't infinity up here. There is no infinity to input, and you can put a really, really, really big number there, and Desmos can handle it. It's a good choice of a calculator to use here. Okay. All right, let's check out our next problem, number 17. Remember, the first thing we want to look for is what is the common ratio? What is that R value? And if we know our sequence formula, then it's really clear to see where the R value is. Here, the R value is 3/5, which does make this a convergent series. You have the choice right here how you want to go forward. Okay, if putting in all those weird parentheses everywhere in sigma notation is too difficult, then go with your convergent series formula. That would be looking like this. The sum of this infinite series, where our first term is negative 6.8 over 1 minus the R value, which is 3/5. I don't know. I think this is easier to put into Desmos than this giant sigma notation, but it does require you to understand the convergent series formula. You should get negative 17 this time. So you choose how you want to input this. I think on this one I'll show you how to do both. I just want you to be comfortable with both. If I choose the convergent series formula, it's fairly simple. Fraction negative 6.8 over 1 minus 3/5. Negative 17 is my answer. If I want to use the sigma notation, the input gets a little trickier, but it's fairly straightforward. They are using a y variable there. So y is from 1 up to infinity. Now I'm just going to go with 100. See if that gets me my final answer. I'm going to input my function. I think the part here that students forget the most is putting these parentheses around this y minus 1 to keep it as the exponent. But either way, you see I get negative 17. So just go with something and be confident in it. Practice makes perfect here, or perfect practice makes perfect anyway. All right, one to go with you on the odd examples. And this one's a quickie. And the reason I know this one's a quickie is because I know my sequence formula. Writing this down again for you. It shows me where the R value is. So the R value, the common ratio, is negative 4/3, which totally stops this problem. Negative 4/3, if you wrote that in decimal, that absolute value is 1.3 repeating, which is bigger than 1. So this is divergent, which means we are done. There is no specific sum of a divergent series. So we are done here, okay? All right, you guys try the odds. Check your work on the answer key. Come find me if you need any help. Happy studying.